Hey, happy 4th of July. Tell you, I've come a long ways, man. Started with the galaxies and stuff like that, worked my way down. I'm designing atomic structures at this point. And no, 99.9% of the world has no clue what I just said, or just laughing, whatever, I don't care. It's not a joke. Anyways, light and electrons. There are entire fields of study that don't know the difference between light and an electron. I kid you not. Entire fields. Usually dealing with the subatomic. Because 9 times out of 10, at this level, they're dealing with electrons. Well, what they call electrons. And it's electricity is what they're talking about. What I call the, electric field. And that's point-to-point energy. It's lightning. So a lightning is point-to-point. In order for it to jump out of the clouds and neutralize itself on the ground, it has to ionize the air. So the electric field, the magnetic field, has to literally collect all these ions together, and then it jumps. Boom, boom, boom. When it has enough power, it jumps from ion to ion to ion, and it fries everything in the process. That jump, that power, is electricity. The light is broadcasted everywhere. The electricity is point to point. The light goes everywhere without caring where it goes. And a lot of people don't understand this. I don't know how. They're so focused on their books that they can't look around, I think. But light, radio, all this other stuff, it transmits, it doesn't care where it goes. There's no wave collapse, okay? But on the atomic scale, they're like it says, 9 times out of 10, they're dealing with point-to-point information, point-to-point energy. So what they're seeing is wave collapse, all right? They're seeing a large wave come over and just go and go into one tiny little spot. That's electricity. Okay, that's what electricity does. When it builds up in a wire because it ran out of room, and we got another wire short distance away, it has to build up enough energy to go boom and burn its way over to the other side. All right, that's electricity. It's not electrons. It goes through walls. It goes through glass. As a matter of fact, we got electron lasers. They start in a glass tube. Particles ain't going through that glass. That's energy is going through that glass. The energy jumps. All right. It's a little spooky at first. And when you really get into it, it's a little spooky, a little weird, but it's not. When you think about it, it all starts to make sense when you start to understand it. Anyways, have a wonderful 4th of July.